Hey Andrew, I got your email about the prime numbers exercise. So I see you're applying Wilson's theorem. That's very cool. I haven't had anybody do that before. I had to look it up myself. So that's a cool theorem. So let's take a look at the implementation here. So we have, oh, and I created a test class and basically all it does is go through and check this is prime function, which I'll show you how I want to do that in here. So basically what I'm thinking is a more helpful implementation here would be just have a Boolean that returns true or false if we have a prime number. And so this would be returning true, and the other, right, if it's prime, it should return true. And if it's not prime, it should return false. We can clean this up a little bit later, but just giving you the idea here. Oh yeah, so this compile problem is already there, right? It looks like what you're wanting to do is compare these values, which means you want to do equals equals, right? And let's see if that compiles. Okay. Oh, and here it says we're missing a return statement. So here it's asking for a value back in factorial, which actually makes a lot of sense. You're trying to access a value here. So what you could do here, in fact, I see you're using this X field. You don't really need an X field, a wider X field that the whole class knows about. You really just need an int right here, X. And you want to initialize this to 1. Because otherwise, every time you multiply, if x starts out as 0, 0 times y is always going to be 0, so you're always going to be loading up x with a 0, which is not what you want. So you want to start out with 1, and then you multiply all the positive values of y and return x. Okay, so now you're getting a value back. It gets us started. Let's see how our test is doing here. So if I run test is prime, it fails on, let's see, test is prime line 47. So let's see here, in our test, line 47 is the first one, so the number 1 is not prime. So actually our test, our test only works for natural numbers n bigger than 1. So we want to make sure we're working with numbers bigger than 1, right? So we can say, well, so we can say, you can say if n is less than 2, return false. How about that? Compile. Oh, I meant y. I was looking at this thing. Okay, so let's see if that works. Test is prime. We got another problem here on line 48. So it didn't work for 2. So let's see why not. So it says, oh, so we want this to be the factorial of y minus 1, right? That's what Wilson says. Start with check. Yeah, we want the factorial of n minus 1. So that's going to be y minus 1 for us. So let's compile that. And see if that works. And it looks like we passed everything. So we could clean this up a little bit too. We could just say return, I say y is greater than 1 and this, right? Because if it's greater than 1, I think if those are both true, it should work. Let's just try that out. Just makes it a little shorter. Do it right? Oh, expected. Oh, sorry. I've been doing a Python class. There we go. So it's and in Java. And let's see if that goes. Test is prime. Yep. Looks like we're good. So yeah, so that's how I would handle that one. But that's cool. Congratulations on finding a very interesting solution using Wilson. That was nice. And I hope that helped. If you have any more questions on this, let me know. There's also a little you can find articles on this in other places too, but there's a little thing on finding factorials using iteration like you did, which is fine, or recursion. So I'll send you this link too. Anyway, again, nice solution, and if you have any more questions on getting how we got it working, let me know.